So this one is a simple example that starts from displacement. So if it starts from displacement, that means everything will be done using a differentiation. So usually I will differentiate first to get all my formula. So obviously the expression can happen in trigo. So if the expression is given to you in trigo, everything will be done in radian mode. So it can also be given in exponential function. So you differentiate everything. Okay, I think this answer may be wrong. Okay, later we shall see. Okay, so basically this kind of question, right, is like answering what they are asking. So I'm interested to find the acceleration when there is an instantaneous rest. That means at the point where it changed position. So at the point where it change direction, v is equal to 0. So you literally do what the question try to ask. So you set velocity to 0. Do take note that when you are doing this, right, it is the change in direction. And that will be the one that we need at the part where we do a change distance travel. So from here, you do your normal algebra. So reject the negative timing. So this is the timing where the direction is changed. And from here, you put the timing into the acceleration. So that's how we get the minus 12 meter per second square. So the next part, I'm interested to find the velocity when it is next at O. So velocity when it is next at O means you return to the original position. So when you return to the original position, so look carefully. So I actually got more than one answer. I will have a t equal to 0. And I will have t equal to root 12, or I will have t equal to minus root 12. So apparently I'll reject the negative timing. And between 0 and root 12, this is the initial timing. So I wouldn't take the initial timing. I will take the next timing. So I should accept the next timing. And then I put into my velocity formula. So you will get a minus 24. So basically you are answering what the question is asking you. So sometimes, but if the question is set in a trigo expression, you will end up solving trigo equation. So solving trigo equation means you actually got to go back to ASTC, basic angle. Or if the expression is set in exponential, that means some amount of logarithm will be used. Okay, so now the critical part is the distance traveled. So for the distance traveled, you are going to use the displacement to trace the position. Okay, so I'm going to erase off everything. The only thing that I'm going to take note of will be the change in direction. So from here, we already know the change in direction happened at 2 seconds. So at 2 seconds, there is a change in direction. So I'm going to erase everything. And focus on the distance traveled. So when we say we want the distance traveled during the first 3 seconds, the word first is important. When we say first 3 seconds, it means, right, it starts from t equal to 0 to t equal to 3. Are there instances where we don't start from t equals 0? Yes. So for example, the distance traveled in the second. So when we talk about second, this is the second block of 1 second. Second block of 1 second. So if we talk about second, right, is t equal to 1 to t equal to 2. So later on, there will be a question that there is a practice question that I put regarding this. So not every time you start from t equal to 0. You got to see the word first 3 seconds, and you start from t equal to 0. So if let's say from t equal to 0 to t equal to 3, the particle travel in a straight line. So you trace the position. You trace the position using the formula. So you try tracing the position. So if you try tracing the position, a lot of people, right, they will tell me that the distance traveled is 9. Yes, the distance traveled could be 9 if it's a straight line. But just now we discovered that at t equal to 2, there's actually a change in direction. So you should go and explore the position where the direction is reversed. So we realize that it's at position 16. So at position 16, the direction is reversed. So we've got to trace the path. So right now we're going to trace the path. From 0, we move to position 16, then we move to position 9. So the displacement is telling you the position. So something like you draw a number line. You draw a number line for the position. So you draw a number line for the position. And you are starting from 0. You move to position 16 before you make a change in direction. So from here, you trace the distance traveled. So the distance traveled will be the 16 and the tiny part here. So that's how we get the 23 meter. So if it doesn't have a change in direction, the displacement, the position will just be the distance traveled. But because of the reverse in direction, there will always be a difference. So it's always necessary that you investigate the change in direction. Could there be 2 change of direction? Yes. So sometimes if we have a lot of zigzag, so there could be 2 change in direction. And since displacement is a position, can I get a negative displacement? Yes, you can get a negative displacement. So if you get a negative displacement, that means the position is on the left side. It's a matter of whether is it on the right side of the origin or the left side of the origin. It's quite possible. So when you calculate distance traveled, you will need to calculate the change in direction.